Today's lesson, section 8.3b, we'll be continuing on talking about polar form of complex numbers. So in the last video I showed you how to change complex numbers into polar form, so here we're going to go backwards and change polar form into rectangular form. So there's your formula for polar form. The z equals r times, parentheses, cosine theta plus I sine theta. So if we distribute that r through, you would get r cosine theta plus I r sine theta. And then the r cosine theta is actually the same as the a value from your complex number. And then r sine theta is actually the same thing as the b value. So then finding what those are, you get your complex number of a plus bi. So if I take letter a from example 4, changing polar form into complex numbers, I distribute the 5 through. Now usually I put the 5 in front of the I, but in this case I'm going to put it behind just because this is going to go as my B and this is my A. So then A should equal what 5 times cosine of 2 pi over 3 is. So cosine of 2 pi over 3 is actually the same as negative 1/2. And then you have 5 times sine of 2 pi over 3. And so sine of 2 pi over 3 is square root of 3 over 2. Okay, so now, let me rewrite that because I don't want that. So there's my b value. So now z should equal negative 5/2 plus 5 square root of 3 over 2 times I. And so that would be my complex number. Let's try another one. So here z distributes your negative or your positive 3 through. So 3 cosine of pi plus I times 3 sine of pi. Okay, so now 3 cosine of pi is going to be, cosine of pi is negative 1. And then sine of pi is 0. So then 3 times negative 1 gets me negative 3. And then 3 times 0 is 0, so then I get just negative 3 for my answer. Right? Now, next thing is we want to be able to multiply and divide complex numbers, but these complex numbers are going to be in polar form. So if I have two complex numbers z1 and z2 and have polar forms as z sub 1 is the following and z sub 2 is the following, okay? Then if I want to be able to multiply them, so that's this first one, then we multiply the r's together, so the radiuses or the moduluses, and then we take a cosine and we add the two arguments together, or the angles, and then we do the same thing for the sine. We add the two angles together. Okay? If you want to do division, you divide your moduli together, and then you subtract your arguments or your angles to each other. Now remember always, the one that's listed first is subtracted from the second, not vice versa. Okay? So let's take example 5 here, and I want to be able to find the multiplication and division of my two polar forms of my complex numbers. So you're given z sub 1 and z sub 2 here. So if I multiply them, that means 7 times 8. And then I take cosine, and I take pi over 6, and I add it to pi over 5. And so then that gets me something that I have to add or combine like terms. So I do the same for the other one. It'll be the same addition of fractions. Okay, so I have to figure out common denominator between 6 and 5, which is going to be 30. So here 7 times 8 gets me 56. Cosine, so then I want to multiply this one by 5 top and bottom, this one by 6 top and bottom. Okay, so then that gets me 5 pi over 30 plus 6 pi over 30. And then together, that would get me 11 pi over 30. So then now, let's simplify both. So 56 times cosine of 11 pi over 30 plus I sine of 11 pi over 30. Okay, so that would be the multiplication. And then here we'll do the division. So 7 divided by 8, then cosine of pi over 6 minus pi over 5 plus I sine of pi over 6 minus pi over 5. Okay, that would be the same thing. So 5 pi over 30 minus 6 pi over 30. So that's going to give us a negative pi over 30 for all of our stuff. Now here one trick is something that we need to remember from our previous chapters from first semester, where we talked about even and odd properties of trigonometric functions. So remember, if you have a negative angle for, let's say, cosine or secant, that makes it, that's like a reflection over the x-axis. So they're like the same x value. So I could say for cosine, this would be the same thing as positive pi over 30. Okay? And then for your sine, that would be a reflection over the y-axis. So that would mean that it's an odd property. So sine, cosecant, tangent, cotangent all have those same properties. So the negative actually comes out in front, and you can write it like this. So negative I sine of pi over 30. And then that would be my final answer. Okay? That only happens when there's negative inside. If it's not negative, then you just keep it the same, kind of like the first one. Okay? And that's it. Have fun.